Okay, so basically, remember that these polygons can be in a circle, like inscribed in a circle. So they call the center of the polygon the center as well, because it's the same idea like as a circle. It's just in the middle, okay? The apothem I'm going to do in pink. So if you want to kind of follow along with that, that's like, it basically goes from the center to one of the sides. Okay. The radius is like, it feels weird because they have a radius of a polygon, which is like, isn't that like circle stuff? But again, like picture the polygon in a circle. The radius, I actually don't draw it there. I draw it strategically right here. And then you can be like, OMG, triangle. Okay. So this right triangle is what makes things like more difficult because they don't usually give you all the stuff for your formula. So again, with this formula here, it's 1/2 AP. So A is the apothem, and then P is the perimeter. So I'm going to use pink and blue for all of that. And that's just like adding up all the sides. So again, basically what you do is like you think about cutting up these polygons into equal triangles. And essentially what you're doing is you're finding the area of all of these. So you're going like 1/2 apothem, right? And then times whatever this is, like the base. Just say it's B. And then you would do, like you'd add up, well, like for pentagon, you would do 5, right? But like for a hexagon, you would do 6, octagon 8, yada yada, right? So this is what I'm saying. Since all those triangles are the same, you can cheat a little. You can like factor out the half and factor out the A, and then what you're left with is a bunch of B's, whatever, how many there are. So like octagon, there'd be more. And this B plus B plus B plus B, if you add those all the B's up, it's the perimeter. So again, I have so many formulas that I have to have in my brain. So this helps me remember them. Or you could memorize it. But it's basically from triangle formula. Okay. All right, so if you notice with all of these, okay, when I draw a radius and apothem, if you draw them strategically, they make a right triangle. And that's where things get like a little on the sassy side. So apothem is from the center perpendicular to one of the sides. I always draw it bottom, like down, you know. You don't have to. I don't know. I just do the same thing because then I don't get mixed up on what I'm doing. So if I draw all the apothems, it's the center to the side, right? Are you writing this down? Center to the side. Then the radius, again, strategically drawing the radius is drawing it here. And then that's where our right triangle begins. So you can use it to like find stuff. Okay. So usually like even, I mean, you could even look quick at some of these examples. Sometimes they don't give you all the stuff. Like they don't give you the apothem or they don't give you sides or anything. So you have to like figure it out. So, and another thing as well, they usually don't use Pythagorean theorem. There's usually like not enough information for Pythagorean theorem. So what you do is you figure out what the angle is in these. So like today, we're gonna focus on the equilateral triangle, the square, and the hexagon for a specific reason. So I'll tell, like you'll see in a second, but it has to do with what those angles are. So to find the angles, you can either memorize this because they haven't changed ever, like it's always the same, or you could do this process. So the process is you picture this thing in a circle. Oh boy. Okay, that looks really bad, but whatever, we're gonna be fine. And so like picture all these guys in a circle, right? So inscribed in a circle is a fancy name for it. And you can see how you can like cut it up in like pie slices in a way. So like the measure of angle 1, do you see how it's like, you see the 3 pie slices, right? So the plan is to try to figure out what this angle is in 2, but like the first step to find the measure of angle 1, you're going to do 360 because it's like in a circle, and you're cutting it into 3 slices essentially. So you're going to divide by 3. So each of these little slices are 120, right? So like each of those are 120. So like if I did it on the square, so measure of angle 1 for the square, I mean this one you probably already know, but that's okay. That would be 360 divided by 4, because you have 4 slices, so that's 90. So all these guys are 90s, you know. And then hexagon, you do the same thing, but there's 6 slices, you know, so you, to figure out like each of the slices, you're going to do 360 divided by 6. So each slice is 60. So all these are 60s, right? But then the key is when you draw the apothegms, like when you draw this guy, you see how you're literally chopping one of the slices in half. Okay, so like all of these, when you draw the apothem, you're cutting one of your slices in half. So to find the measure of angle 2, I kind of covered it up with my marker. You're going to take the 120, cut it in half, is 60. So this angle right here is 60. And it is 100% all the time, equilateral triangle is 60 right there. So you can either keep that in your head or do this process, right? Square is 100% of the time. If I took 90 and cut it in half, this is always a 45. Okay. So again, like we're going to be focusing on these triangles here because that's going to like help me find stuff to find area. So like every single time to find this little angle, you're going to take 360 divided by a number of sides and then cut that in half. So every single time for a hexagon, that's a 30. And then if they make you find the measure of angle 3, which usually I don't bother with, like if you needed to find this guy, you would just do like 180 minus 90 minus 60. Like you would do the triangle stuff. But you guys already know it's 30, 60, 90. But, and then same for this one. This would be 45. And then this one would be 30. But like if you need to figure out that angle. But usually for me, personally, I usually just figure out this angle because then I can figure out the rest fine. Okay. So we'll probably just do 4 of these and then have more work time for you guys. To hopefully, you should finish it in class. So that'll be the plan. Okay, so for this one, okay, the formula is the same. So the formula is 1/2 AP. And what's great is they give you the apothem. It's 4. So cool. I can put a number in. But you don't have anything else. So that's what most of them are like, where you have to like figure out stuff. Okay. So the plan is you have to try to figure out this little chunk. That's the plan. Figure out that little chunk. Double it. And then multiply by 3. So perimeter is the worst. Because you have to like figure out the little chunk on the triangle, double, and then multiply by 3 because there's 3 sides. So if you were to like, say you totally forgot what we just did and you forgot the angle measure, because you can't do Pythagorean theorem because there's not enough stuff, you can always go back and fall back on your pie slice thing. You could take 360 divided by 3 is 120. So 120 divided by 2 is 60. So this is a 60-degree little right triangle. So your focus is on this like little dinky triangle. Okay, so you've got the 4. You need to figure out this guy. And then you've got nothing on the hypotenuse, but you know it's a 30, 60. So you should be using your special right. We're not doing trig, you're doing your special right stuff. So for a 30, 60, 90, if you forgot everything, you cannot forget this anymore, okay? This is the hypotenuse is always double, and the long leg is always scaled by root 3. So you're going to be kind of figuring that stuff out with all of these guys. So here, 4 is the short leg, which is the best scenario because it's across from 30. So what I'm going to do from short to long, I'm going to multiply by root 3. So that'd be 4 root 3, but you can't get excited. That's not the perimeter. It's just this like little dinker over here. Okay, so that's just a little 4 root 3. So you're going to double it to get the side. So 8, right, for the side. So then the perimeter, you triple it because there's 3 sides. Okay, so it'd be 24 root 3. And that's what you tap in your calculator. Okay, so I usually go 0.5 times 4 times 24 times square root 3 and hit enter. And then I don't know, I forgot what the answer was. I think I wrote it down tonight. It was 83.1 units squared. Okay. So, yeah, you're just doing special right stuff to figure everything out. Okay. So it takes a while to get the stuff. And like number 2 is the worst because they give you nothing. And then you're like, well, what do I do? What's that angle? Oh, wait, it's the exact same. We just did it. Hello, every triangle is the same, 60. Okay, so put that in your brain or do your little 360 divided by 3 and then cut it in half. Either one. So we need to figure out all the things. And all we have is a dinky 12. So that's cool. So we've got the 60, we got a 12, and we need the, well, I guess I have to do the Popham because it's short leg. Okay, so 30, 60, 90 rules. The hypotenuse and short leg are double in half, so that's going to be 6. Okay, that wasn't that horrible. But perimeter is the worst because you got to do all this, like, keep track of your numbers, right? So again, I'm going to figure out this little chunk. So I divide by 2 to get the short leg, but then I multiply by root 3 to get the long leg. But don't get excited because that 6 root 3 is just like this little dinker guy. So that means you got to like double it, times by 3, all that stuff. So you're going to double it. And then your perimeter is 3 times 12 root 3. So 36 root 3, and then you just tap that guy out. And you get your answer. So basically people forget like to double it. You know what I mean? Like they take the 6 root 3 and then just times by 3. So like you just have to be careful on where you're getting all your numbers essentially. And you get 187.1 units squared. Okay. All right, square. Now you can do the 1/2 AP, but I'm a little sass with this because I think that's harder. So you can do 1/2 AP, like go live your best life, but I'm like, why? Because all we need is a side. That's what I'm saying. Like you could just do the side and square it like the normal square. Do you know what I'm saying? So like I sometimes do that. Well, actually not sometimes, kind of like all the time because I think that's faster. But you'll get the same answer if you do the 1/2 AP business, okay? So, I mean, either way, I do have to do some triangle work, but like my plan is I'm going to get this little chunk and then double it so then I could just throw it in the formula. And then you're like, I forgot the angle. And then you can just be like, oh yeah, I just do 360 divided by 4. Right? Because then you get all your little pie slices, and then you take your 90 and divide it by 2. So this is a 45er. Oh my gosh, a 45, 45, 90. Okay, so then you can do 45, 45, 90 stuff. We've got the 20 root 2. And then you're going to use that to get your this little chunk. So then you can double it and put it in the formula. So for 45, 45, 90s, that's all about root 2. So this is just straight up 20. Okay, don't get excited. That's not the side yet. You've got to double it, 40. So your area, all you need is the 40, and then you square it. So it's really not, I like the square the best, personally. Because all you need is the 40, square it, 1600, done. Okay. Any questions so far? We can skip 4. We'll go to 5 and we'll call it, okay? All right, hexagon. And we're given nothing. Yay. All we're given is, well, we're not given nothing, but it's still not as cool. Okay, so I'm going to set up my stuff. I need 1/2 AP, and I don't have either, so cool. And then you're like, I forgot what angle's in there. Oh, remember, you could just go 360 divided by 6, and then cut it in half. So again, you can do that every single time, to get it, but this is a 30-degreer. You can commit that to memory or do the process again. Okay, so that's always like, oh my gosh, 30, 60, 90, woo. Okay, and then I'm like, I like doing a bottom first because it's A. Well, too bad. You have to find the short leg on 30, 60, 90s first. So I have to figure out that little chunk first. So hypotenuse to short leg is always double in half. So this is going to be half because I'm going long to short, So 8√3, if I divide it by 2, and again, don't get too excited, that's just this little dinker. So if that's 8√3, I'm going to double it, 16. And then for my perimeter, I have 6 sides now. And maybe some of your brains are like, well, why don't I just multiply 8√3 by 12? Yes, go for it. As long as you organize your math in your brain, I don't care, okay? You just have to keep track of where all your numbers are, okay? So this is what, 96, right? Yeah, okay. 96√3 is your perimeter. So we did the hard one first, I guess, right? So we got your short leg, double, multiply by 6. Perimeter done. Apothem. Okay, what do I do with that? So that's short to long is what? √3. So then I got to go short to long, so I got to multiply it. Ew, this is ugly. 8√3 times √3. Actually, just kidding. This will be cute. Because it'd be 8, and then √3 times √3 is just 3, right? Yeah. So it's just 24. Right? So here's the thing. People are like, well, I'd rather divide by 3. Well, it doesn't matter what you like, Like, of course I'd rather divide by 3, but that's not what you do. You got to multiply because it's long leg. You know what I'm saying? That's happened on tests before. That's why I got to tell you. So just make sure you're double, triple checking all your little steps. Okay, so 1995.3 units squared was the answer once you tapped it out. So, any questions at all?